Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we'll be learning about the filters, ripple voltage and diode current. Okay, so here's the circuit for the ripple for the filter circuit. So basically, once you have the input there, once you have a sinusoidal input coming, and then this input can come from a rectifier. So you can be a full wave or half wave rectifier. Then it will go through the diode over here. Then there's a capacitor and a resistor, and the voltage is taken across the resistor here. Okay, so this is the circuit. First, what happens is, if you look at in the graph over here, if you look at the graph over here, you will see that the dotted line is the input. So it can come from a half wave rectifier, for example, and then the black line here is the output voltage. So starting as the input voltage increasing positive over here, this is positive cycle. What happens is this voltage will go through the current. There will be a positive voltage. So there will be a positive voltage over here, P connected to positive and connected to negative, means that the diode is in forward bias. So what happens is, the diode will be turned on. So the diode will be turned on, then it means that there will be current flowing, and it will start to charge the capacitor over here. Okay, so the capacitor will be charged, positive, negative over here. So what happens is, during this period, the first until the peak of the input, there will be charging of capacitor. So the output voltage, and there also be current, right? The current it will charge the capacitor, and also current goes to R. So as the input voltage increases, also the current will increase. So the current will increase to R, so V out will be the same as the resistor, as the voltage across R, so it will increase nicely. However, the output voltage is slightly less than the input because there's a drop, right? V gamma, we assume there's a V gamma over here, so there's a drop across the diode. Once it's at the peak here, right? So once the voltage reaches its peak, and begin to decrease. So when it starts to decrease, this part, the voltage across the capacitor starts to decrease or discharge. So now it means that after it comes to the peak here, you have fully charged the capacitor, right? But now the voltage at the capacitor is more than the input voltage, because the input voltage is going down. So what happens is the capacitor will take charge. So now once the capacitor voltage is higher than the input voltage, now it means here now it's reversing. Oops, sorry. So now it's reversing. It becomes let's choose another color. So it becomes now becomes positive, negative here, because now the voltage at the capacitor is greater than the input voltage. So now the diode is off. Okay, when the diode is off, what happens is the capacitor will start to discharge over here, right? So there will be current flowing. So that's how you see then after the first cycle here, it will start. You have some output current here, output voltage. This output voltage is due to the current when the charge discharges from the capacitor. So you have current flowing, and you will see the capacitor will start to discharge slowly. So the shape is like this because the capacitor starts to discharge. So the voltage, so the maximum voltage of the capacitor when it's fully charged is Vs minus V gamma, right? The peak, it was the secondary voltage minus the call it, the drop across the diode. Okay, so this drop, this discharging will follow the discharging of a capacitor, and this will decrease exponentially. Okay, based on the RC times constant. I think you learned this before. And during this time the diode will be off, because as I mentioned before, this voltage at the capacitor is bigger than the input here, so it become plus minus over here. Now okay, then what will happen? So it will keep on decreasing, the output will keep on discharging here until this point. Okay, so what happens here? Until there's a point which the input voltage is greater than the capacitor voltage, because you remember this capacitor here is discharging, so there will be a point where it will loses the voltage or the charge until Vs here gains more voltage than here. It means that now it's reverse. The diode will turn on again. So at this point, you can see here, the point where it's charged to increase again is where the diode will turn on again, because you already loses the charges in the capacitor, which and it discharges to the resistor. Then the charge will be less, hence this will be, the diode will be forward bias again. And again the same thing happens. You can this will it will start to charge again, right? This part, it will start to charge the capacitor again until it's the maximum, then it will discharge again. So you can see the overall shape of the output voltage will look like a ripple over here. So it means that the circuit, you can, the dotted line here is from the half-wave rectifier, so you can see very nicely it's being filtered away. Okay, right. So this is if they ask you to draw the output for the RC filter, they would look like this. Okay, now this is the graph showing the time. This is the voltage, okay, against time. So you will see can see very nicely. So this is the period of charging the capacitor, where the diode is on, and then this is where this region here is where the discharging of the capacitor, and the diode is off. Okay, and this will keep happening again and again. And if you draw the current versus time over here, it similarly you can see it's similar. It will follow, because V equals to IR, and then R is just a constant, so the shape of the I will follow the shape of the V, so similar. Okay.